Module 4 focuses on Azure Storage Solutions. This introductory slide provides an overview of Azure Storage Services. Azure Storage is a comprehensive, highly scalable, and secure cloud storage solution designed to meet diverse data persistence needs for modern applications. It offers a robust foundation for various cloud workloads. Azure Storage encompasses distinct services, including blob storage for unstructured data like images and videos, file storage for managed file shares, queue storage for asynchronous messaging between application components, and table storage for NoSQL key attribute data. These services are engineered for exceptional durability, high availability, and global accessibility, ensuring data integrity and continuous operation. Azure's infrastructure provides built-in redundancy, geo-replication options, and comprehensive security features, making it a cornerstone for resilient cloud architectures. Azure Storage offers a foundational set of capabilities, beginning with exceptional durability and high availability. This is achieved through built-in data replication, which stores your data across multiple data centers, ensuring persistence and enabling business continuity even in the face of regional outages. Secondly, Azure Storage provides massive scalability and flexibility. It dynamically scales from gigabytes to exabytes of data automatically, supporting diverse data types including unstructured blobs, structured files, queues for messaging, and NoSQL tables. Finally, robust security and compliance are paramount. Azure Storage incorporates comprehensive data encryption, both at rest and in transit, leverages role-based access control for granular permissions, and adheres to a wide array of global regulatory standards, providing a secure and compliant platform for your critical data assets. Azure Storage accounts serve as the foundational component for all Azure Storage data, acting as a unique namespace within the Azure cloud environment. This account provides a distinct address for accessing all your stored data objects, ensuring both organization and security. Azure offers various types of storage accounts designed for different workloads and performance requirements. The most common and recommended is General Purpose V2, which supports all Azure storage services, including blobs, files, queues, and tables. Specialized accounts like Block Blob Storage are optimized for high-performance block blob storage, and file storage accounts are dedicated to premium file shares. A critical aspect of Azure storage accounts is the concept of storage tiers. These tiers, namely Hot, Cool, and Archive, are designed to optimize costs based on your data access patterns. The Hot tier is ideal for frequently accessed data, offering the lowest access costs and highest availability, though with higher storage costs. The Cool tier is suitable for infrequently accessed data that needs to be stored for at least 30 days, providing lower storage costs compared to Hot, but with slightly higher access charges. Finally, the Archive tier is for rarely accessed data with flexible latency requirements, typically stored for 180 days or more. It offers the lowest storage costs but incurs the highest access and retrieval fees. Understanding and correctly applying these tiers is crucial for effective cost management within your Azure storage solutions. Azure Blob Storage stands as Microsoft's robust object storage solution within the Azure cloud ecosystem. It is specifically engineered to accommodate vast quantities of unstructured data, a category encompassing virtually any type of data that does not conform to a relational database schema, such as images, video files, audio, documents, log files, and backups. This service provides a highly scalable and exceptionally durable platform, ensuring data resilience and availability. Data stored within blob storage is accessible globally via standard HTTP and HTTPS protocols. A key feature of blob storage is its support for various access tiers: Hot, Cool, and Archive. These tiers allow organizations to optimize costs by matching storage performance and pricing with their data access patterns and frequency requirements, ensuring an efficient and cost-effective data management strategy. Azure Blob Storage is purpose-built for storing vast quantities of unstructured data, encompassing diverse formats such as images, video files, audio recordings, and various documents. Its high scalability and cost efficiency make it an indispensable asset for applications requiring extensive object storage. A key strength of blob storage lies in its capabilities for archiving and long-term data retention. Through its tiered storage options, hot, cool, and archive, organizations can strategically manage costs by aligning data access frequency with the appropriate performance tier. This renders blob storage an optimal choice for comprehensive backup and disaster recovery strategies, as well as for meeting stringent compliance requirements for data archiving. Additionally, its robust infrastructure forms the foundation for data lakes, facilitating big data analytics, and serves as an efficient backend for content delivery networks. Azure Blob Storage serves as a cornerstone for two critical modern data strategies: content delivery and data lakes. For content delivery, Blob Storage provides highly scalable and durable storage for static web assets, including images, videos, documents, and downloadable files. When integrated with Azure Content Delivery Network, it enables global distribution of content with low latency, ensuring an optimal user experience for website visitors, streaming services, and large file downloads, regardless of geographic location. This infrastructure is essential for media companies, e-commerce platforms, and any organization requiring efficient worldwide content distribution. Regarding data lakes, Azure Blob Storage offers an ideal foundation due to its ability to store vast quantities of raw, multi-format data, be it structured, semi-structured, or unstructured, at petabyte scale cost-effectively. This makes it perfect for housing the raw inputs for big data analytics, machine learning, and artificial intelligence workloads. Data scientists and analysts can leverage this centralized repository to derive insights from diverse datasets without the upfront need for complex schema definition, fostering agile data exploration and advanced analytical processing. It effectively democratizes access to data for innovative solutions. Azure File Storage provides fully managed file shares in the cloud, accessible via industry-standard Server Message Block or SMB, and Network File System or NFS protocols. These cloud file shares can be simultaneously mounted by Azure Virtual Machines, allowing for shared application data, and by on-premises clients, facilitating hybrid cloud scenarios. This service eliminates the operational overhead of managing file servers and storage hardware. Azure File Storage integrates seamlessly with Active Directory for identity-based authentication, enhancing security. It supports diverse workloads from general-purpose file sharing to application-specific storage, offering high availability and durability. Its scalability ensures that storage capacity grows with demand, making it a robust solution for modern enterprise requirements. This slide focuses on file storage use cases for lift and shift applications. A primary scenario involves migrating existing on-premises applications that have dependencies on file shares directly to Azure without requiring extensive code modifications. This strategy allows organizations to modernize their infrastructure by moving workloads to the cloud while minimizing disruption. Additionally, Azure File Storage enables cloud-native applications to access shared file storage for various purposes, such as storing configuration files, application data, or user content, ensuring a consistent and scalable data layer. Finally, it supports legacy applications that require traditional SMB or NFS protocols to operate effectively within a robust cloud-based environment, preserving functionality while leveraging Azure's benefits. Azure File Storage serves as a robust solution for centralizing shared application settings. This approach ensures consistent configurations across multiple application instances, simplifying management and enabling unified updates from a single authoritative source. Furthermore, file storage facilitates the efficient distribution of common utility scripts, deployment tools, and diagnostic utilities to various virtual machines or containerized environments. This ensures all operational components access necessary resources for maintenance and troubleshooting. Lastly, it provides a centralized repository for aggregating logging and diagnostic files from distributed services, enabling comprehensive monitoring and streamlined analysis, ultimately enhancing operational efficiency and environmental consistency. Azure Disk Storage provides persistent, block-level storage specifically designed for Azure virtual machines. It ensures data remains intact even when virtual machines are deallocated or restarted, a critical feature for applications requiring durable storage. Azure offers a range of disk types, each optimized for different performance and cost requirements. Ultra disks deliver the highest throughput and IOPS for the most demanding workloads. Premium SSDs provide high performance with low latency for production applications. Standard SSDs offer a cost-effective solution for less demanding workloads, while standard HDDs are suitable for archival or infrequent access data. These disk types can be configured as operating system disks or data disks, offering flexibility for various VM configurations. Furthermore, Azure Disk Storage boasts high durability with data replicated multiple times to protect against failures, and offers scalable performance, allowing administrators to adjust disk sizes and performance tiers dynamically to meet evolving workload demands. When deploying virtual machines in Azure, selecting the appropriate disk storage is crucial for optimizing both performance and cost. Azure provides 3 primary disk storage options to cater to diverse workload requirements. First, standard HDDs or hard disk drives are the most cost-effective option. They utilize traditional spinning platters and are best suited for workloads that require infrequent access, such as backup, archival, or development and testing environments where performance is not the primary concern. Next, we have solid-state drives, which come in 2 tiers, standard SSDs and premium SSDs. Standard SSDs offer improved performance over HDDs with lower latency, making them suitable for web servers, lightly used enterprise applications, and development workloads. Premium SSDs deliver significantly higher performance and consistently low latency, powered by flash memory. They are designed for I/O-intensive production workloads, including databases and high-performance applications that demand fast and reliable data access. Finally, Azure Ultra disks represent the pinnacle of disk storage performance. These disks are specifically engineered for the most demanding, mission-critical applications that require extreme throughput and IOPS with consistently low latency. A key advantage of Ultra disks is their unique ability to independently configure IOPS and throughput, allowing for precise performance tuning without changing the disk size. This flexibility makes them ideal for large databases, SAP HANA, and other high-transactional systems. Disk storage is foundational for workloads characterized by high input/output operations per second, often referred to as I/O-intensive workloads. These environments demand low latency and high throughput to maintain performance. Consider high-performance databases, including online transaction processing, or OLTP systems, and various NoSQL databases. These applications execute millions of read and write operations daily, where the speed of data access directly impacts application responsiveness and user experience. Disk storage, particularly high-performance SSDs, are critical for handling these rapid, concurrent operations efficiently. Secondly, data warehousing and advanced analytics platforms rely heavily on robust disk storage. These systems ingest vast quantities of data, often terabytes or petabytes, and then perform complex queries that read and process large data sets. Efficient disk I/O ensures timely data loading and accelerates query execution, which is vital for business intelligence and reporting. Finally, virtual machines and containerized applications frequently exhibit demanding storage performance requirements. Whether hosting critical business applications, development environments, or high-traffic web servers, these virtualized environments require disk storage that can sustain their operational demands without becoming a bottleneck, ensuring smooth, uninterrupted service delivery. Azure Disk Storage plays a pivotal role in 2 primary use cases: hosting databases and serving as operating system disks for virtual machines. For database hosting, Azure Disk Storage provides the high-performance, low-latency storage essential for demanding transactional workloads, ensuring rapid data access and processing. This is critical for enterprise applications requiring reliable database operations. Concurrently, OS disks utilize Azure Disk Storage to deliver persistent, high-speed storage for the virtual machine's operating system, boot volumes, and all installed applications. This persistence is fundamental for maintaining system state and ensuring that VMs can be reliably stopped, started, and restarted without data loss. Furthermore, Azure Disk Storage offers advanced features such as disk bursting for unpredictable performance demands, shared disks for clustered applications like SQL Server failover cluster instances, and comprehensive snapshot capabilities, all of which are crucial for maintaining database resilience and preserving OS integrity. Azure Queue Storage provides a robust messaging service for large volumes of messages. Its primary function is to decouple application components, allowing independent operation and enhancing system resilience. Producers can send messages to a queue without needing direct knowledge or synchronous interaction with consumers. Conversely, consumers can retrieve and process messages at their own pace, accommodating varying workloads and preventing bottlenecks. This asynchronous communication pattern enables applications to scale independently, recover gracefully from failures, and process tasks reliably, even under heavy load. It is an essential building block for constructing scalable and fault-tolerant distributed systems within Azure. Azure Queue Storage is fundamental for implementing asynchronous messaging patterns, which are crucial for building scalable and resilient cloud applications. Firstly, it achieves significant application decoupling. By placing messages in a queue, producer components can dispatch tasks without direct knowledge of or dependency on consumer availability. This isolation enhances fault tolerance and allows independent scaling of different application parts, improving overall system robustness. Secondly, queue storage ensures highly reliable asynchronous message delivery. Messages are persisted and remain in the queue until successfully processed and deleted by a consumer. This at least once delivery guarantee means that even if a consumer fails or becomes unavailable, the message will eventually be processed, preventing data loss and maintaining data integrity. Finally, queue storage is instrumental in orchestrating complex distributed workflows. It enables various worker roles, Azure Functions, or other compute services to consume tasks from a shared queue, processing them in parallel or sequentially as required by the business logic. This facilitates the creation of robust, scalable, background processing systems and long-running operations. In essence, Azure Queue Storage provides the backbone for building responsive, scalable, and resilient distributed systems by enabling efficient and reliable asynchronous communication. Azure Queue Storage is a foundational service for achieving robust workload distribution and scaling. A primary use case involves the decoupling of application components. By acting as an intermediary buffer, queue storage enables different parts of an application, such as a front-end web service and a back-end processing engine, to operate independently. A producer can enqueue messages without awaiting processing, and a consumer can dequeue and process messages at its optimal rate. This separation enhances system resilience and modularity. Beyond decoupling, queue storage facilitates asynchronous message processing. This is particularly valuable for handling long-running or background tasks, such as complex calculations, report generation, or bulk data operations. Rather than directly executing these tasks and potentially blocking the main application thread, the application simply adds a message to the queue. Dedicated worker roles can then process these messages in the background, ensuring the primary application remains responsive and performant. Crucially, queue storage is instrumental for dynamic workload distribution and load leveling. During periods of fluctuating demand, messages can accumulate in the queue during peak loads. Multiple worker instances can then be deployed to process these messages concurrently, effectively distributing the workload and preventing system bottlenecks. This inherent capability allows applications to scale out efficiently, handling increased loads without requiring significant architectural changes, thereby optimizing resource utilization and maintaining service levels. Azure Queue Storage plays a pivotal role in enabling robust inter-service communication within distributed applications. Its primary function is to facilitate asynchronous message passing between decoupled application components. This design pattern allows services to operate independently, sending messages to a queue without requiring an immediate response from the consuming service. Secondly, queue storage acts as an effective buffer for requests, efficiently managing load spikes for services with fluctuating processing capacities. Messages can accumulate in the queue during high demand, allowing consuming services to process them at their own pace, preventing system overloads. Finally, it ensures reliable communication in distributed systems by persisting messages until they are successfully processed and deleted. This guarantees that critical data or commands are not lost, even if a consuming service experiences temporary downtime, thus enhancing the overall resilience of the application architecture. Selecting the appropriate Azure storage solution is paramount for optimizing performance, cost, and manageability of your cloud applications. This decision begins with a thorough evaluation of your data's inherent characteristics and its expected access patterns. Azure offers diverse services like blob storage for unstructured data, Azure Files for shared access, table storage for NoSQL key-value pairs, queue storage for message queuing, and managed disks for virtual machines. Each is designed for specific use cases, and matching your data type, whether archival, transactional, or analytical, with the right service is fundamental. Secondly, consider your application's performance, scalability, and durability requirements. Performance metrics like latency and throughput are critical for ensuring responsive applications. Scalability is essential to accommodate future data growth and fluctuating demand without manual intervention. Durability, achieved through features like geo-redundancy and multiple data copies, guarantees data resilience and availability even in the face of regional outages. Finally, factor and cost optimization, security, and compliance. Azure provides tiered storage options, enabling cost reduction by moving less frequently accessed data to cooler tiers. Robust security features, including encryption at rest and in transit, role-based access control, and network isolation, are integrated into all storage services. Adherence to industry-specific compliance standards and regulatory requirements must also guide your selection. An informed decision across these dimensions ensures your storage strategy aligns perfectly with your business and technical objectives. This module provided an in-depth exploration of Azure storage solutions. To summarize and implement best practices, first, selecting the optimal Azure storage service is paramount. Whether utilizing blob, file, queue, table, or disk storage, the choice must align precisely with your data's access patterns and the application's specific requirements to ensure efficiency and functionality. Second, robust data security must be a foundational pillar. This involves implementing comprehensive encryption at rest and in transit, leveraging Azure role-based access control and shared access signatures for granular access management, and employing network isolation through private endpoints or service endpoints to protect data integrity. Finally, optimizing for both cost and performance is crucial for sustainable cloud operations. This is achieved by strategically employing data tiering for different access frequencies, automating data lifecycle management policies, and selecting appropriate redundancy options such as locally redundant storage, geo-redundant storage, or zone-redundant storage based on your resilience needs. Adhering to these principles ensures a secure, high-performing, and cost-effective Azure storage infrastructure.